Hey guys, this is the polynomial test walkthrough. This is the version for people that are not afraid of factoring trinomials. I have another video if you want to see how to do all this without factoring. Factoring is your friend though. It makes it an easier test. Problem number one, when I look at this, I see that it has quadratic form. It's a quartic equation, but it's going to factor into two quadratics. So all I need to do is find the numbers that multiply to get negative 10 and add to get negative 3. That's negative 5 and positive 2. And your four solutions are going to come from, two are going to come from x squared minus 5, and the other two are going to come from x squared plus 2. So just take each one of those factors one at a time. When does x squared minus 5 equal 0? You can subtract 5 and take the square root, and you get positive and negative square root of 5. Perfect. Those are two of your solutions. The other two solutions are going to come from x squared plus 2. When I take away 2 from both sides and take the square root, notice that I'm taking the square root of a negative number. That means I'll have an imaginary solution. So my four solutions are going to be positive and negative 5, square root of 5, and positive negative I root 2. All right, the second equation, the second problem, works similarly. You can factor that into two quadratics. Think of numbers that multiply to get negative 45, but add to get negative 4. Solve each one of those factors and generate two solutions. So let's figure out what x squared minus, when is x squared minus 9 going to equal 0? When x is positive or negative 3. Let's solve x squared plus 5 equals 0. Take away 5, take the square root. Again, you take the square root of a negative number, so we're talking about positive and negative I times the square root of 5. All right, for problem number 3. This is not a problem that is in quadratic form, but it kind of is if you factor out an x. X is common to all three of those terms, so go ahead and yank an x out of each one of those terms. The resulting quadratic in parentheses can factor. So find the numbers that multiply to get 6 but add to get 7. We're talking about positive 6 and positive 1. So now I have my three factors. Those are going to generate my three solutions. What makes x minus 1 equal 0? Negative 1. What makes x plus 6 equal 0? Negative 6. And what makes x equal 0? 0. So my three solutions to that cubic are just negative 1, negative 6, and 0. For number 4, there's no structure there that I can take advantage of, so I'm actually going to go over here to my calculator. I'm going to graph that function. And I'm looking for where it crosses the x-axis. It's a cubic equation, and I'm seeing it crosses the x-axis 3 times. So all three of my solutions are going to be real numbers. That's great. And it looks like they're going to be, let's see, can I even pick out what those numbers are? It looks like one of the solutions is going to be negative 4. So let's put negative 4 in the box and do the synthetic division thing. All right, and I end up with no remainder on the end. So negative 4 is definitely one of my solutions. I need to find the other two. You can do that by also plugging those numbers into doing synthetic division. But I usually like to just grab those coefficients and just solve the quadratic that's there. So x squared minus 2x minus 8, when does that equal 0? That'll give me my final two solutions. This is one that factors. It factors to negative 4 and positive 2. Okay, so what makes x minus 4 equal 0? 4. What makes x plus 2 equal 0? Negative 2. There you go, you're done. Those are your three solutions. Negative 2, positive 4, negative 4. And of course, you can see that on the graph. You can see what those solutions were going to be. All right, moving on to number 5. Number 5, again, I don't see any groupings that I can take advantage of. I'm going to have to graph it and see what happens. Now, when I look at the crossing points, I see the graph touches the x-axis at negative 1. I see it kind of hits a point between 0 and 1. Maybe that's going to be some irrational number, maybe. And then, and it looks like 5. All right. So I can start anywhere I want to. I'm going to start over here at negative 1. And you see how the graph touches the x-axis? It doesn't cross through it at negative 1. It actually just touches the x-axis. We got a multiplicity there. So I'm going to do the synthetic division thing with negative 1. Let's see, times the number in the box, add the column, times the number in the box, add the column, times the number in the box, add the column, times the number in the box, add the column. Hey, no remainder. So you see, negative 1 is indeed a solution. But negative 1 is going to have a multiplicity of 2 right there. So that means I can do negative 1 a second time. So put negative 1 in the box again and do synthetic division a second time. And again, you'll see there's no remainder. Negative 1 worked twice, which is great. That's called a multiplicity. Well, now I've knocked it down to a quadratic, so I can just grab those terms and just the 3x squared, the negative 16x, and the 5, and I can just solve that quadratic with whatever means I want. It does factor. I used the box method, and I ended up getting 3x minus 1 times x minus 5. And those factors told me what my solutions would be. That first set of parentheses, what makes 3x minus 1 equal 0, positive 1/3, and what makes x minus 5 equal 0, positive 5. So my 4 solutions are 5, a third, negative 1, and then negative 1 again. All right, and for the last problem, let's see. This is a cubic equation, so I'm going to try and get 3 solutions. I see that all 3 solutions are going to be real numbers because the graph crosses 3 different times. It looks like I can try. It looks like those 2 on the right are not going to be integers. So let me start with the one that is an integer. Let's start with that crossing point at negative 5. Do synthetic division. Hopefully I'm going to get no remainder here in a second. Correct. Okay, no remainder. So negative 5 is indeed one of the crossing points. But rather than try and mess with trying to figure out what those decimals are, I'm just going to solve the quadratic that's there. Solve the 2x squared minus 4x minus 8. This is not a quadratic that factors, so I'm just going to use the quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. And when you simplify all that, you end up getting 1 plus or minus the square root of 5. So my 3 solutions are 1 plus the square root of 5, 1 minus the square root of 5, and negative 5. All right, on to the back. So now we're going to have to deal with all this vocabulary. But in order to see what I'm looking at, I'm going to need to graph that equation. So I throw that into my calculator, graphing it. I'm actually going to make my window go a little lower and a little higher so I can see the where the top and bottom of this thing are. Oops, hold on. Go ahead and, I gotta make that negative 60. Got it. All right, there we go. So we got a nice quartic looking equation. I'm going to use my calculator to find all of the critical points. I'm going to try and find those minimums, those maximums, and those x-axis crossing points. The x-axis crossing points are actually pretty easy to get. That one's at negative 4. This one's at negative 1. The next crossing point is at 1. And then the 4th crossing point is at 3. So those are my 4 zeros. I'm also going to need to grab the minimum and maximums. So let me go take a minute and go calculate the minimum value down here, the minimum of that chunk. My calculator tells me that that minimum is negative 2.94, comma, negative 48.13. All right, I got another minimum to find, so let me use my calculator to find that minimum. All right, that second minimum is 2.22, comma, negative 19.06. Those values are coming straight off of my calculator. There's also a maximum, a local maximum. Let me go ahead and grab that. My calculator tells me that that maximum is at negative 0.04, comma, 12.02. All right. So that's everything we're going to need in order to answer all of these questions. All right, so domain. Domain for polynomials is easy. It's all real numbers. It's everything from negative infinity to positive infinity. Done. All right, what about the range? When I'm looking at this graph, you might notice that this graph doesn't go any lower than that y value. What is that y value? Well, it's negative 48.13. So I'm going to write my range as bracket negative 48.13, comma, infinity. So it's everything from negative 48.13 and up. For the relative maximum, there's only one relative maximum. It's that little point in the middle. That location, my calculator told me, was negative 0.04, comma, 12.02. What about the absolute minimum? There are two minimums here, but one of them is the most minimum. That one that is lowest is called the absolute minimum. And we already saw that that was the coordinate of that minimum is negative 2.94, negative 48.13. All right, intervals of increase. That is, when is this graph heading uphill? So here's a section that goes uphill, and here's a section that goes uphill. There's two increasing sections, which I've just drawn in green. So tell me where the graph is increasing. We have that first bit of increase from negative 2.94 to negative 0.04. That's that section. But then I have another chunk of green uphill that goes from 2.22 all the way up to infinity. So there's two regions, and I'm just joining them together with a union symbol. Intervals of decrease, that would be everywhere else. So basically the places where the graph is going downhill. I'm seeing that it's decreasing all the way down from negative infinity down to negative 2.94. Then it goes up for a little bit, but then it's decreasing again from negative 0.04 to 2.22. Positive intervals. That is, where is the graph positive? So I'm just going to grab this sticky note and cover up the negative part, and let's look at the three places where the graph is positive. You have one chunk of positiveness everywhere between negative infinity and negative 4. Then you have this little like peaky bit in the middle that goes from negative 1 to 1. And then anything beyond 3, so from 3 to infinity, that's increasing. Decreasing, negative intervals, that's everywhere below the y-axis. So it looks like there's two kind of U-shaped things. We just need to write those coordinates, or that range. So the first one is, it's negative between negative 4 and negative 1. The second one is negative between 1 and 3. All right, and then for this last problem, we want to see, is the leading coefficient positive or negative? I see that this graph is ultimately heading uphill, so it's got a positive leading coefficient. Is the degree odd or even? I know that graphs that start low and end high have odd degrees. Is the function odd? Does it have odd symmetry? Is it symmetric about the origin? No. Is it symmetric about the y-axis? No. So that means it has neither kind of symmetry. So it is neither odd nor even. And then if I count the straight line-ish pieces, that tells me that there's 5 pieces. It's 5th degree, which jives with the idea that it's an odd degree. And that concludes this.